Hey guys, so the main thing we're going to talk about today is what is known as geometric mean. It still uses a proportion, it still relates to similar triangles, but it sort of gives us a shortcut around actually finding the similar triangles in a picture. So first thing, let's talk definition. The geometric mean between two numbers is the positive square root of their product. So to find the geometric mean between value A and value B, you're going to set up this proportion. A over X equals X over B. Every proportion is solved through cross multiplying, right? So if I were to cross multiply what sits in front of us, X times X is going to be X squared. And over here would be whatever we get when we multiply A and B together. This is going to be an equation we can solve because I can take the square root of both sides and we'll get a value for X. This is the math essentially that you're going to be asked to do today. So if we start first with problems that give you the two values and simply ask you to find geometric mean. In other words, set up that proportion. So if my values are 4 and 9, I'm going to have the first fraction as 4 over X, second fraction as X over 9. Okay, cross multiply. X times X is always X squared. 4 times 9 in this case is 36. I don't want X squared, I want X, so square root both sides. And that means that my value for X in this case is 6. 36 is a perfect square. It gives me a whole number answer. That's all that I need. If I do the same thing on question 2 here in the middle. So if I start with my fractions, 6 over X and X over 15. And I cross multiply, so I get my X squared. And in this case, 6 and 15 make 90. Okay. The key here now is if I go to square root both sides, 90 is not a perfect square. So how do I handle that? Well, this is why we did that quick review, because I'm going to ask that you provide me a simplified square root and a decimal to the nearest tenth, much like we did earlier in the year. So keep in mind, you can either break this down right inside your work, or you can sort of have a piece of scratch paper where you do your factor trees, whatever is easier for you. If I break down the 90, 9 and 10, that gives me 3 and 3, that gives me 2 and 5, right? Locate those pairs that are going to go on the outside. So that means that my value of X is equal to 3 on the outside. Inside I have the single 2 and 5, so that means 10. You also want to get a decimal answer. Type the square root of 90 into your calculator, not 3 square root 10. Just in case something went wrong with your tree, typing the square root of 90 gives you an accurate decimal. In this case, to the nearest tenth would be the decimal 9.5. Question 3 is asking you to do the same thing, except now my values already have square roots. But I'm going to go with my same setup. So I have 2 square root 2 over X. And then my second fraction is going to be X over 3 root 2. When I cross multiply, X times X is always going to give me X squared. This is where we need to multiply these correctly. Multiply the fronts. 2 times 3 makes 6. Inside, 2 times 2 makes 4. At this point, I would normally square root both sides, but I don't want to put one square root over top of another. So I need to simplify this right-hand side first. So look at what you have. You have a square root of 4. We know that the square root of 4 is 2. So this side here right now is actually saying 6 times 2 because the square root of 4 is 2. So I can rewrite my problem as I still have an x squared, and we're going to be equal to 6 times 2, which is now 12. And so at this point, now I can square root both sides, because now my right-hand side is just a whole number. And when I square root, if I need to, I can break down this 12. 4 times 3, 2 times 2. And I'm going to end up telling and getting an answer that x is 2 root 3. And if I put the square root of 12 into a calculator, I am going to get the value of 3.5.